Okay, lesson 1-7, computing with scientific notation. First thing I want you to do is make sure you put a little bit in your notes about the idea at the top of the page there. And remember, we can use products of powers and quotients of powers properties in order to solve these problems. Okay, you'll see exactly what that means after this first problem, I'm confident. For example number 1, we have 7.2 or 7 2/10 times 10 to the third, and then we don't even have a multiplication sign in here, it's implied multiplication. That quantity multiplied by 1.6 times 10 to the fourth. Well, we can use the fact that these are both expressed in terms of scientific notation in order to make this problem easier. What we can do is we can group things using the associative and the commutative properties of multiplication, and we can multiply these four numbers in any order that we want. So we're going to take the 7.2 and the 1.6, we're going to multiply that together. And the reason we do that is because we can take the 10 to the third and the 10 to the fourth power and multiply that in our heads very easily and get 10.7. Now all we have to do is multiply 7.2 times 1.6. That will yield 11 and 52/100ths. However, this is not properly stated here in scientific notation, so we have to change 11 and 52/100ths times 10 to the seventh, take that number and change it to 1.152 times 10 to the eighth. We move the decimal point over 1, so we have to multiply it by a larger number in order to end up with the same number. So that's what we're talking about by using the products of powers and quotients of powers properties, by handling the powers of 10 and then doing the rest of the problem. Please press pause and do letters A through B. Example number 2. We have a situation where we're told in 2010 the world population was 6.8 billion, we'll call it. In fact, later on we're going to actually just use the number 7 billion in order to do this problem. That's the way they did it in the book, so we'll stick with that. The U.S. population was 3 times 10 to the eighth, and then they ask how many times greater is the world population than the U.S. population. So we have 7 times 10 to the ninth, which would be the 7 billion, divided by the population of the U.S., the 3 times 10 to the eighth. Well, 10 to the ninth divided by 10 to the eighth would be 10 to the first. So all we have to do is divide 7 divided by 3. And believe it or not, you can do this in your head if you think about it. 7 divided by 3 would be 2 1/3. And 1/3, of course, is 0.3 repeating. So 2.3 repeating times 10 to the first. We can move the decimal point over and just answer in a standard form number and say that the world population is about 23 times that of the U.S. Please press pause and do letter C. Example number 3. First of all, put an explanation of place value and using place value when solving scientific notation problems from page 61. Put some of that in your notes, and of course add this to your notes as well. So example number 3, we're asked to evaluate it and then report our answer in scientific notation. So we have the quantity 6.89 times 10 to the fourth, and we want to add 9.24 times 10 to the fifth. Well, the first thing we need to recognize is we can't add 10 to the fourth and 10 to the fifth. That's not going to work. So we need to either change this to 10 to the fourth or this to 10 to the fifth. And in the way they do it in the book, they move this to 10 to the fourth, but you're going to see that the better way would have been to go the opposite way. We'll talk about that more in a minute. So if we drop this down to 10 to the fourth, then we obviously need a correspondingly larger number here to end up with the same number. So since we move this by one exponent, we're going to move the decimal point one place, and we're going to make this number larger. Remember, don't think of right and left, think of bigger or smaller. We have to make this bigger in order to make up for the fact that we made the power of 10 smaller. Move the decimal place once, and we have 92.4. Now we can add the 6.89 and the 92.4. 6.89 plus 92.4, and then use the reverse kind of distributive property to take the 10 to the fourth out of both of these quantities. This is an important thing to learn how to do this. This is just distributive property in reverse. So it's 6.89 plus 92 and 4/10 times 10 to the fourth power. However, once again, can add this up and we get 99.29 times 10 to the fourth, but this is not proper use of scientific notation. We have to make this smaller so that it's between 1 and 9. Move it over to here and we get 9.929 times 10 to the fifth power. And that's our answer. Example number 4. Some more practice with this type of thing. 7 and 83/100ths times 10 to the 8th, and we're going to subtract 11,610,000 from it. So the first thing we do is turn this into scientific notation. By the way, what you could do is you could turn this into standard form, do the problem, and then turn the standard form answer into scientific notation. That would be perfectly acceptable to do. We're going to teach you how to do it this way. So this becomes 1.161 times 10 to the 7th. We move the decimal point 7 places, so you can see that right away. 3, 6, and 7. Okay? So now we've got 7th power here and 8th power here, so we move this one to 7th power. And again, I'm going to say, actually, I would have done the opposite. I would have made this 8th power. You're going to see that in the coming problem. So we have 78.3 and 1.161 times 10 to the 7th. And we're subtracting. So we can take 78.3, we're going to subtract 1.161, and then all of that gets multiplied by the common power now of 10 to the 7th. 78.3 minus 1.161 is 77.139 times 10 to the 7th. We need to move the decimal point over to here. 7.7139 times, we moved it 1, so we have to bump this up 1, 10 to the 8th power. If we had done it the other way, by changing this, we wouldn't have had to do that second step. You'll see a sample like that real soon, I think, this problem here. Example number 5, 593,000 plus 7.89 times 10 to the 6th. Put this in scientific notation, which I think you're familiar with now. I'm not going to go through the steps. 5.93 times 10 to the 5th, we moved it 5 places, plus 7.89 times 10 to the 6th. So now in this case, they changed this one to a 0.593 times 10 to the 6th. Because we went smaller here, we have to go larger here to make up for it. Now they're both the same power, so we can use the 10 to the 6th, but we have 0.593 plus 7.89, and we don't go past the 9's digit here, so we don't have to do that extra step. This was a good way to do this problem. If you don't understand that, make sure you see me in class about that. After you do 2, 3, 4 of these problems, you start to realize that you can pick the right one and go the right direction, and you eliminate that one extra step. So in this case, we have 8.483 times 10 to the 6th. Please press pause and do letters D through F. Here are your solutions to the letter problems. Section 1-7. Letter A, we have 8 4/10 times 10 to the 2nd power, all times 2.5 times 10 to the 6th power. So we can group this 8.4 times 2.5 right here, and all of that multiplied by 10 squared times 10 to the 6th we can do in our head is 10 to the 8th. And then we've got this times this is 21 times 10 to the 8th. Again, we have to have the decimal after the first digit, so we have 2.1 times 10 to the 9th. Kick it up 1. Letter B, we have 2 and 63/100ths times 10 to the 4th times 1.2 times 10 to the -3. So we can group the 10 to the 4th and the 10 to the -3 and get 10 to the 1st. The 2 and 63/100ths times 1 and 2/10 right here. Multiply that out and we get 3.156 times 10 to the 1st. And since we have it after the first digit, we're complete. Letter C. They're asking how many times larger is Lake Superior than Lake Ontario. Lake Superior is 8 times 10 to the 4th square kilometers, and Lake Ontario is 18,610 square kilometers. Now remember before I said that if you want to, you could conceivably turn this number into a standard number and just do the math that way. If you did it that way, this would be 80,000, and 80,000 divided by 18,610 would yield this answer here. I carried it out to that many digits just to show you that you could if you want to. Or you could do it the way they've been showing you in the book and change this one to a scientific notation format. So we have 8 times 10 to the 4th divided by 1.861 times 10 to the 4th. They're both in 10 to the 4th, so that's going to work there. And basically we just still have, again, 8 divided by 1.8610, which is going to yield the same number. For some reason in the book, they rounded this to just say Lake Superior is about 4 times as large as Lake Ontario. Letter D, 8.41 times 10 to the 3rd plus 9.71 times 10 to the 4th. We choose to get this one to 10 to the 4th. We have 0.841 times 10 to the 4th plus 9.71 times 10 to the 4th. Looks like we've got a good solution here because we should have a number that's small enough. We will have 0.084 plus 9.71 times 10 to the 4th. Unfortunately, this is just enough to push us over the 9 digit here. We end up with 10.51 times 10 to the 4th. So we still have to have that extra step. We move the decimal place over to here. We have 1.0551 times 10 to the 5th. Doesn't always work out when you choose which one you're going after, but that's generally what you're looking for, is that when you add these two numbers up, we're going to have a digit here between 1 and 9. Letter E, 1.263 times 10 to the 9th minus 1.525 times 10 to the 7th. The obvious solution here is to go smaller here. Okay, so we moved, and we have to go 2 decimal places, so we moved it from here to here. So now we've got 1.263 times 10 to the 9th, and we're just going to subtract this small piece from it, also times 10 to the 9th. So our answer is going to be 10 to the 9th, and it was going to be 1.263 minus 0.1525. This right here, put it in the calculator, it's 1.24775 and times 10 to the 9th. Letter F. We have 6.3 times 10 to the 5th plus 2.7 million. This, we should learn to be able to look at this and see that this is 2.7 million, which tells you automatically it's 2.7 times 10 to the 6th. 10 to the 6th is a million. So now we've got it 10 to the 6th and 10 to the 5th. So we want to change this one to a smaller number because we're adding these, and we're still probably going to end up between 1 and 9. Obviously we will in this case. So we have 0.63 times 10 to the 6th plus 2.7 times 10 to the 6th. Our answer is going to be obviously times 10 to the 6th. 0.63 plus 2.7 is 3.33 times 10 to the 6th. Please do guided practice.